Hey, hello there. So today's Leetcoding challenge question, it's the maximum sum of circular subarray. So we have a circular array of integers. You can imagine it's a bunch of integer numbers that forms a cycle, and it's represented by a regular array, so it's a straight line. But to be able to model this cycle here, once we reach the end, we go back to the beginning. So we need to find a maximum possible sum of non-empty subarray of C. So if you consider this as a ring, as a circle, we're taking a portion of the circle, but that circle, that portion cannot be greater than the whole circle. And for the portion, we want the numbers, the sum up to be the maximum possible. So that's the question. I guess this primary difficulty is just to deal with the fact it's a circular thing, but it's represented in a it's a 2D, basically it's a 2D thing, but it's represented as a one-dimensional thing. So if it's a purely one-dimensional, meaning that we don't have the circle, it can be solved by just sliding windows. The algorithm is called Cadence algorithm. And just before we go into detail about Cadence, I guess most people should familiar with this kind of question can usually be solved by a sliding window or prefix sum. Prefix sum facilitates a sliding window. That's if you consider a function called a cum I, which is going to be the sum of the numbers from this array from the beginning to up until the i's location. Then if we plot this against the I index, it will look like maybe something like starting with some negative numbers and then starting to see some positive numbers, maybe have some hiccups going down again, and positive number after that going up, and then going down. This time we are going really deep, I guess. It doesn't hurt, just throw a little bit spike in there, going quite down, and recovering from that again. So yeah, I guess so. This is the if you plot the accumulation of prefix sum against the location I, it will look like something like this. And in fact, effectively, what the Cadence algorithm, the maximum subarray sum that solves this 1D problem, no cycle, is identify a low point here. Let's call it maybe A, and we find another position B here, such that the height difference between these two things are as high as possible. You know that this cum B subtracted by cum A, it's gonna be sum of A up until B subtract sum of from the beginning up until the location A, which is equivalent to, say, it's the sum of the subarray from A to B. So that's pretty much this height difference between A and B. So we are scanning through this from left to right, and we consider the upward hills, and we want to find the upward hills that has the maximum difference between the highest point and the lowest point. That's what the Cadence algorithm gets you, which is the solution to the maximum subarray sum. And this question is a little bit difficult since that it consider circular. So when we reach the end, we have a little, indeed have a little upward trend there, which with a height difference 3, 1, 2, 3, and we can actually continue towards the left. We do have some going downward trend, but we can go back to B again. So the difference is going to be 1, 2, 3, and going down. So 3 become 2, 2 become 1, 1, 2, 3, 4, 3, 4, 5, 6, 6. So it's actually higher than consider A to B. So let's just call this point maybe like C. This is the end. This is the beginning. Let's just call it S, starting point and end point. So this is the case where the regular maximum sum array, subarray sum, the cadence algorithm will fail in this case because it couldn't resume from E and consider these upward trend here. So how can we modify the maximum subarray sum algorithm to incorporate with this kind of a situation? There is a little bit. You need a little bit tick to get the idea. We can prove that if we can stitch up C to E with sum from A, this array from C to B, it's a cycle. So you reach the E and you go back to S and finally go to B. Is maximum. Subarray sum. Then B has to be maximum of A, and E has to be just gonna put an equal sign there. So the reason being that we can prove this by contradiction. If we have a point that's before B, from A, before B, but after A, that's after S actually, that's higher than B, then we can effectively just move the B towards over there to get a even higher stitched together subarray sum. So this will be violate. If we have something that's after there, then since C is the global minimum, if we have a B that's if we have something that's higher than B after B, then how should I say it? If we have a point that's higher than B in two sections in between B and C, then we can just move that high point B to that location. Then we have this to be highest. Yeah, no matter the high point is between S and B or B to C, as long as it's before C, we can just extend the upper bound to that even higher point to have a higher circular subarray sum. If it's in between C and E, meaning that if we extend to that point from C, we will we actually it's no longer the cycle. It's directly from C to B, C to the highest point, and that will be if that's the case, the cadence algorithm will actually just catch that. So that means circular here. I should make this is a strict. It has to be from the stitched together two parts. Have to go back, go beyond the end and go to the beginning. So if the B is between S and C, we could extend this value to be that highest point to have this to be even higher and still the circular kind of a strict circular fashion. If it's between C and E, we don't need the circular subarray sum. We can just get the regular subarray sum to be this maximum. So it's a similar rationale to the C. You can kind of work on that by yourself. It's a similar reasoning. And since that this is a global maximum and this is the global minimum, this downward here it's basically the minimum subarray sum. So we can just modify the cadence algorithm to find this B to C and have the total summing everything up, which is sum from S to B, B to C, C to E, and subtract the minimum subarray sum. What gives us is S to B plus C to E. So then we just compare this zigzag, this patchwork, combining two upward hill, whether that's larger than the just the largest upper hill we can find by using Kadang, then whichever is larger, we will return that. The only pitfall is that if the whole thing is negative, on the negative side, it's always downward, then the total subtract the minimum, the global minimum, is gonna be what's that gonna be? The minimum subarray sum is gonna be just the whole thing. So the total subtracted the minimum subarray sum will be 0, and 0 will be actually larger than maximum subarray sum, because maximum array sum, when we work up with strictly downward, everything is negative. It's picking the smallest negative number, so we just need to handle that a little bit. So that's kind of the graphical way of looking at this question and reasoning how to modify the Kadang's algorithm to solve this problem. We need a couple of variable, total 0, current mean, current maximum, minimum sum, which initially is the opposite, int max, and the maximum sum, which is int minimum in the beginning. Then we're just going to loop through this array, treat it as a regular array, loop through it once. The update rule is total is always going to be incremented by the number. Let's work with current maximum, because it's the OG Kadang. It's maximum between, let's say we include this number or just that number alone. So the Kadang current maximum's role is to keep track of the current maximum, upward trend. And if we have a single number that just shoot up and makes this previous upward hill, it's kind of useless, then we just use that number. Because you just consider that number alone. If you treat this as the beginning, then it's elevated from, you pretty much restarting. And that's the update rule for this. Minimum is similar, it's just on the opposite side. Maximum sum is the maximum between this one and the current upward height difference in the upward trend. Minimum is similar, but on the other direction. So in the end, we should just if this thing is smaller than 0, it means it's negative all the way, then we should actually return this. Otherwise, it's going to be the maximum between maximum subarray sum, which is the highest upward trend within this regular array, and the total subtract the minimum sum, which is exclude this highest the highest downward trend and use the other upward trend, and combine those two things together. So that's that's the only case where the circular subarray sum is different from subarray sum. So we just consider that, add that as a candidate and do a comparison. Whichever is larger, we return that. And yeah, this is pretty much the code. Okay, so yeah, that's it. It's accepted. And this algorithm is pretty clearly it's a linear time and constant space. I guess to realize this is the highest point and this is the lowest point, it's a little bit tricky. And if you get the click or tick, like then you will be able to have this simplified, very simple and elegant solution. Yeah. So that's for this question.